And now we are live. So welcome everyone. We're so glad you've joined us today. So before we get started, I have to say something. Sitting in front of me are two people that I genuinely wish had taught me maths growing up. Better yet, I wish I had these books when I was at school. I think maths would have felt a whole lot less intimidating. So, welcome to you two. I'm joined by Penny and Sally, the authors of the Balut Maths Handbook and Study Guides and Workbooks for grade 4 to 6. And together, they bring more than 60 years of teaching experience, and they've helped countless learners build confidence in maths. They have a wonderful way of making maths feel approachable and practical and easy to understand. And yeah, so I would just like to welcome Penny and Sally. So I just
Thank
want to
you,
say
Ina.
welcome, guys.
Thank you.
So, throughout today's session, we'd love for you to ask questions in the chat, and then afterwards we'll answer the questions when Penny and Sally have spoken. And then we'll also send everyone a recording of this webinar along with the slides, and then a free sample pack for you guys to get a nice understanding of what the books are all about and how they will help you. So, with that, I'll hand over to Penny and Sally. Thank you so much for being here, and thank you for joining us today. We hope you enjoy the session. So, before they start, we're just going to have a look at the program to see what exactly you're getting yourself into today. So, Penny and Sally are going to introduce themselves. They're going to talk about how the books originated and what makes the book special, and how you can also get the most out of the books, whether you're a parent or a teacher. Um, and then we're also going to look at practical teaching tips and ideas. They're going to share some reviews from people who've used the books, teachers especially, and parents. And then we're going to look at the questions that you guys have for us. So over to you guys.
Well, thank you so much, Ina. It's a bit scary. I've had my internet went down about 5 minutes ago, and I was scrambling around to get it up again. When this is not something that we're used to doing, so please excuse us if there are a couple of technical hitches, but I'm sure that Ina has it in hand. So, as she has mentioned, we both are qualified teachers. And we have taught in both state and independent schools, mostly independent schools, but a few years in state as well. Penny, over to you.
Right. Sorry,
Go
back one.
Yeah.
Sorry, you can see uh oh my goodness me. Sally was supposed to be doing the sharing. And
Yeah,
of course,
slideshow.
with her
Yeah.
internet challenges, I'm now doing it. So I started out as a teacher of maths and science for high school before ending up in the senior primary phase, where my passion for education really developed. It became my mission to understand more about how we learn, learning styles, multiple intelligences, and learning difficulties. As head of academics, I spent an immense amount of time in analyzing curricula, finding the best ways of ordering and presenting content. My first love has always been maths, and I'm particularly interested in how concepts develop from first principles. This has now led me to write grade 1 to 3 resources as well, with an experienced foundation phase and remedial teacher.
Well, I actually have to confess to something. I hated maths at school. I didn't do particularly well at it. And when I look back, it was because I had poor teaching in particularly late senior primary and middle school. And I just believed that I would never be good at maths until I got to university and had a brilliant lecturer who told me it was absolute rubbish. Anybody can do maths. And I really believe that a lot of it is about confidence and building confidence, and getting on top of things, making sure that you never miss one of the foundation blocks. So I taught generalist subjects from grades 4 to 8 for many years. And then in the last 10 or 12 years of my teaching career, I was appointed head of maths in the senior primary, and I focused on that as my specialization. Both Penny and I are absolutely passionate about maths education, and particularly the way children develop their mathematical thinking. And together we've had vast experience with both mixed ability classes as well as with top sets and gifted children. And we are particularly interested in higher order thinking skills. And we're both involved in setting papers for the South African Maths Challenge, which is a national competition run by the South African Maths Foundation. If you're a teacher in a school and you've never done that challenge, I would really encourage you to sign up for it next year. There are tens of thousands of children all over the country who write that, and we are involved in setting the papers for that.
So Sally and I were both in Durban, and we often met each other at inter-school events and meetings. And of course, we spoke about nothing but maths. And after we both retired, we had a mutual desire to make use of the extensive notes and worksheets which we had developed during our teaching careers. So this was where the idea of writing resource books was born. We established our Fundamentals Learning website in 2019 when we launched our first Maths Fundi study guides for grades 4 to 7, the books you see on your screen at the top. Fundamentals is in fact a play on the words fundamentals and fundi. And after numerous requests from teachers, we produced the companion workbooks, which you see at the bottom of your screens. In 2022, edition 2 was published, the result of all 8 books being revamped and improved. And in fact, every subsequent Maths Fundi impression saw further corrections and improvements as we strive for perfection, which we have learned is a rather impossible goal. Despite the challenges of self-publishing and limited marketing opportunities and doing everything ourselves, only the two of us, by the end of last year, we had over 40 schools using our books as their main resource for their classes, as well as scores of parents and teachers in other schools.
Next slide, Penny. Then in July 2024, we started discussions with Penguin Random House about the possibility of them taking over our books. And the plan was to rebrand them as the Burlet books that you see in the bottom row. Renette Lombard, along with Nandi Lessing-Fenter from Penguin, introduced the color and the new images to make the books attractive, fun, and child-friendly. The structure and actual content remains 99% as per our original Maths Fundi books. Apart from the use of color and the different images, the only other change is that the workbook is now one book rather than the 2 separate ones that we had as Maths Fundi, and the answer book is now at the back of Burlet's study guide rather than with our Maths Fundi workbooks. Sadly, Penguin saw our books after they'd already engaged other authors for their grade 7 book. So Maths Fundi grade 7, the blue books that you saw on the previous slide, remain with us as a seamless continuation of the content and structure from our grades 4 to 6 books.
Makes these books special. So, the first thing we feel is so important. We have extensive experience in senior primary classrooms. We understand the progression in cognitive development and maths topics. We know what works and what doesn't work, and we are aware of the common misunderstandings and pitfalls for children. And we all know that many primary school teachers are not maths specialists and fear their maths lessons. Our books give them the correct framework and help so that they can go into their classrooms with confidence.
Right. One of the methodologies that we are particularly keen on using is called the CPA approach. That stands for the concrete, pictorial, abstract. And I'll explain what each of those means. So this is very common for those of you who have heard of or use Singapore maths methodology, and it allows learners to work from what they can see and feel, that's the concrete, to what they can draw, to what they can conceptualize abstractly. Now, many high school learners still need to work in a concrete way, and yet so many resources, even senior primary resources, assume abstraction. So here's a good example of the three. Look at the top image, the counters. The concrete is to use actual counters that can be held and manipulated. The pictorial is where the learners draw their own shapes, and they don't have to be circles, they can be dots or stick figures or whatever, to represent these physical numbers. And then the abstract is where the actual digits are used. If you think of that 2 plus 3, that 2 has no real meaning or significance to two counters. But it's an abstraction. And children need to understand what abstractions mean once they have worked with the concrete and the pictorial. Penny, yeah.
This is an example of bar models, which is also pictorial representation. They clearly show the relationships between the numbers involved. There's a special explanation, a whole section in the last chapter of the study guides for this very useful tool. There are also many examples in the workbooks with the corresponding answers. The concepts of perimeter, area, volume, surface area are often huge areas of confusion for children. I am guessing that teachers who are attending today are all nodding their heads and say, yes, yes, most certainly. And it is so vitally important that the CPA approach is used here. So often, the formula is given to learners before they understand the reasons for the formula. You cannot tell them that area is length times breadth until they fully understand the concrete, where they are using real squares, counting the physical squares, where they understand the pictorial, where that concrete object is done in picture form and with a simple square or rectangle showing the squares. And finally, they can develop the abstract formula for themselves. Then it will make sense, and they are not going to get confused with all the different formulae.
Now, this next slide shows the way, this is from one of our study guides. It shows the way in which we demonstrate in pictorial form as well as abstract, so the numbers of the abstract and obviously the diagrams of the pictorial, how we would add a mixed number and a mixed number. So we've done the color coding where they split up the mixed number into whole numbers and into fraction parts, put them all together, and then simplify the answer in the end. And of course, the ideal is that they do that using, Cuisenaire blocks or counters or something concrete to start with. And this is from the grade 4 book, but it actually would apply to all grades, particularly where learners are struggling with fractions. I know fractions is often the area that gives the most problem for teachers. And it is because it is so abstract if they're not working with something in front of them that they can actually cut up and divide and manipulate. Right, the next slide shows that all the concepts in the book are firmly built on prior knowledge. So we have a lot of cross-referencing. And you'll see the red arrows are pointing to a little gray thing. It says ref with a light bulb next to it. Ref obviously stands for refer, and those numbers will refer to the sections in the study guide that connect with this. So when they are doing squares and square roots, you'll see that they get told that they will need that when they come to area. And then the middle screenshot shows that when they're working in the units for area, the reference refers them back in the book to the first chapter, to that squares and square roots. And when they're working in units of area, units of measurement for volume, they're comparing the cubic measurements with the square measurements, and there's a reference there to area. So often, children get lost in the early years because they've learned sections in silos and they don't see them as connected pockets of information. And we try to connect all those silos so that they can see the relevance of one section with another.
Topics are all explained in detail, step by step. Prior knowledge leading to new concepts is not assumed, so we show basic steps such as this. We give reasons behind the methods, not just a formula or a shortcut. If you look at the bottom part of the screen, is showing the shortcut. So this example, converting mixed numbers to improper fractions. The concept would have been introduced earlier, as Sally has just explained, using concrete and pictorial steps. If the child is using the abstract shortcut, but doesn't understand why this works, there will no doubt be times when they confuse the shortcut steps. And this is where we also stress that learners need to develop a feel for numbers so that an answer makes sense and is not clearly nonsense. Estimation skills are, of course, the central part to all of this.
Right, problem solving. This is our passion, and this is a critical part of our books and of the way that we have always taught. It's so often feared and avoided by learners and teachers who regard it as a nice to do at the end of term when we've finished all our tests, but it should actually be a core component of every lesson. Now, there are two ways of looking at problem solving. So the low threshold, high ceiling concept, okay, the low threshold, everybody can get started, all right? So they've got the prior knowledge, the basic knowledge, but they have to use that, and it's fairly easy to get positive feedback and to feel good about it. Then the high ceiling concept, just click the next click, Penny. The high ceiling concept is where everybody can get stuck. And this is important because in problem solving, there should be problems that are easy and give positive feedback, but we don't want all problems to be easy because that's not real life. If children have to actually work at something and develop grit and resilience and the ability to apply previous fruitful strategies that they've developed, this then assists them in just life skills. So the problems that we have put into the workbooks and the study guides have a combination of these easy, simple ones that are low threshold, very more challenging ones that are more high ceiling. And we explain the heuristics or methods that one can use. At the back of each study guide, there's a whole chapter on these heuristics. And at the back of the workbooks are examples of problems that would use each of those heuristics. So they definitely work in conjunction with each other. And I do know from experience that once children have been exposed to certain types of problems and certain heuristics in solving them, when they see something that is similar, they go, oh, I think I've seen something, looks a little bit like this before, and they can draw on that previous knowledge. So we find that children who do particularly well in the maths challenge and in various Olympiads are those who have had a lot of practice on past papers, and they recognize this is something that I have done before, and I will just apply that knowledge in this context.
Critical thinking is encouraged throughout the books, and it's not only relevant in problem solving. It is a crucial part of the step-by-step process to develop deeper understanding, the why, the when, the what if types of questions. This particular example from Study Guide Grade 4 compares factors and multiples. And we know that these two concepts often confuse children. So after they are introduced individually using arrays, we look at them together. And there we have the corresponding section in the workbook where they are challenged to think deeply and critically. This example explains multiplying and dividing by powers of 10. We do not tell a child to just add a 0 when they multiply by 10. They need to understand that each digit is increasing in value and the zeros are place values. Following on from this simple fact, we move on to long multiplication. We tell them, write a 0 in the second row when you multiply by the tens digit. And how often do children not forget to do this? Maybe if they understand why it needs to be done, it will become more entrenched as part of this whole process. At the bottom of the screen, that little example, the writing, that compares area and perimeter and is a lovely practical exercise which deepens understanding of these concepts. And this type of question is accessible to all ability groups.
Right. Then when we come particularly to fractions, this is an area that we have debated long and hard with high school teachers, because of course in high school they use the improper fraction method, which you will see there on the right, where they work in all their addition and subtraction, as well as obviously multiplication, division, one has to do improper, but even in addition and subtraction, they work with those. We have found in our experience that children do not really understand the value of an improper fraction, and through most of primary school. I remember once I was doing a locum for somebody. It was actually a grade 7 class, and she left them some word problems. And the one problem was Mary Jane is doing long jump. In her first jump, she jumps 3¼ meters. In her second jump, she jumps 3 1/8 meters. What is the difference between your two jumps? And these children were changing everything into improper fractions and doing the subtraction. And I said, but they're both 3 meters. So all you've got to look at is 1/4 minus 1/8. And I then said to them, all right, I want you to all come out into the playground, and I want you to tell me how far 26/7 of a meter is. And they had no idea. But when I said 3 5/7 of a meter, they could more or less show me where that was. And so we prefer using a mixed number method, at least up until grade 6. But we show both, because we do believe that apart from pleasing the high school teachers and introducing the improper method, we know that children think in different ways. And so we show both methods, and we encourage them to use the method that works for them. And we just hope that their teachers are not being prescriptive.
Here are a few examples of the practical application of concepts. I shall bring them up slowly so that you have a moment to glance through the questions. Maths needs to be a real tool applied to everyday life and not just a theoretical subject. How often do we not hear questions, especially as children get older? Why do I need to know this? How will this help me in life? So it's so important in our primary school years that they see the relevance to real life, that they see the application to real life.
But we stress the need for the correct use of maths language and terminology. It's important that learners are able to articulate their thinking accurately and clearly. So we encourage them to explain aloud how to solve a problem, whether in class, to their parents, to their teddy bear, whatever, to be able to use the correct words. And, I've got a 5-year-old grandson, and he was telling me the other day the names of about 30 different dinosaurs. Some names were probably 10 syllables long. And I think, well, if children can remember dinosaurs' names, they can certainly learn correct maths terminology.
The books also have many suggestions for class discussion and investigation. And teachers are encouraged to engage learners and not just be the font of all knowledge. Children get great satisfaction out of showing something new to their peers and their teacher. Do not skip these suggestions. This is often where the real learning and deeper understanding takes place. We will show you some examples on a workbook slide a little later.
Right, so in our books, you will see two things, enrichment and extension. Now, enrichment is a widening of knowledge, which is not always from a higher grade or necessarily complex. And here you see some examples of enrichment where we do give background history of things. You can see moon phases, Gauss's method of adding numbers, calendars, bit of background on how calendars and years and months and days work, just to give that little bit of extra general knowledge. However, then extension, which is the next slide, is where we're introducing a topic, perhaps from the next grade, but not necessarily higher order. So in CAPS, temperature is not covered in grade 4, but grade 4s they're used to hearing about temperature. And so we introduce it as what we call a little extension topic. In grade 6, the powers of 2, we introduce, because at the bottom there, you'll see the binary system. A lot of grade 6s are very interested in coding and in computing. And we say, well, that's based on the binary system. And let's explain how that works. When I was at school, we had to do calculations in base 2 and 3 and all sorts of other things. So, we've put that in the books. It's obviously not something compulsory for the children to cover, but we do think that it adds a lot of interest to them.
In compiling our original Maths Fundi books, we often consulted high school teachers to ensure that we were using terminology and methodology correctly and as they wanted it to be. And we are lifelong learners. We've never stopped expanding our knowledge.
Right, let's talk about how the books work. So we are very much of the opinion that particularly primary school children need to be working with old-fashioned paper and pen, that this hugely outperforms keyboard and screen as far as connecting all the neural pathways. We don't want children who can flick through a screen in their sleep but can't draw a straight line with a ruler and a pencil. So our books were designed for 3 particular sets of audience in mind. The first, obviously, is teachers, and you'll see up there, I'm not going to read it to you. You can see what we had in mind for the teachers. The second group, obviously, is the learners. And we've had a lot of feedback from learners who say, I was too embarrassed to say in class I didn't understand, but I went home and read it up in the study guide, and now I do. Or, of course, they might have missed a lesson. Or they're using our study guides to revise for an assessment coming up or exams. And then the parents. Those arguments? This is the way I did it at school, dear. You must do it this way. And the children say, but my teacher teaches it a totally different way. This is where the parents can look at the study guide and see the way that they are probably being taught at school.
So topics in the books have been deliberately arranged in content areas rather than in CAPS order. Firstly, because many schools using our books follow other systems, such as the IEB and Cambridge. But more importantly, this ensures correct flow and progression of concepts, which is often a huge challenge in CAPS ordering. For example, in grade 7, they do financial maths at the beginning of the year, but they don't even have a thorough understanding of what a percentage is yet and how a percentage relates to a decimal or a fraction. Section numbers correspond across the study guides, workbooks, and answers. and all are identical to the original Maths Fundi numbering.
Sorry, Penny, I'm just going to just interrupt you for one moment there, because I'm not sure whether we said it. So although we've got the books in content order, we do not want teachers to start in chapter 1 and teach all the way through to chapter 18 or 19. Within each content order, there is a clear progression. So you wouldn't do, for example, area or volume before you've done perimeter, and you would before that have to do measurement length, basic length. But it doesn't mean to say that teachers can't do something from the numbers, relationships, and operations, and then do a little bit of geometry, and then maybe do some data handling, and then come back and do fractions. So within the content areas, there's an order, but teachers are very much encouraged to jump between one content area and another within a term. Sorry, Pena, I interrupted you there.
No, absolutely. That was a very important point. Thanks, Sally. Yes, so the aim is to achieve mastery, and mastery needs working with a single concept, or working with a concept and its related concepts thoroughly and not jumping around. The spiraling comes in extra mental tests, routine tests, assessments, in revision, or whatever the teacher sets. So the other question, the other point that we need to explain, having a single book with a study guide, the workbook, and the answers all combined, as are Burnett's grade 7 and high school books, would result in a very heavy and bulky single book, which is not ideal for little people. We also know that teachers need to take books with workbooks home to mark, and that learners may need the study guide to revise at the same time. The teachers don't need access to the study guides, to every child's individual study guide. They only need to see the workbook section. The decision was therefore made to use 2 books for these 3 grades. And we're well aware that this means purchasing 2 books. So we'd like to leave you with a thought there. Compare the cost to parents of a single evening of takeaways for the family with books which will be used for the entire year and can make a huge difference in their child's future. Food for thought.
Right, the study guides. This is where we show how everything works, and we have worked examples. The cognitive development of mathematical thinking has been very carefully considered. So the grade 4 book in particular has lots of diagrams and suggestions for hands-on activities with physical equipment. As we've mentioned before, there's background information, things that we think are interesting for the learners, but also to help them understand how maths is developed and fits into the real world. The last chapter in the study guide introduces the specific strategies or heuristics for problem solving. I mentioned that before. We believe that exposure to this and practice in this will make a huge difference in their higher order thinking skills.
We move on to the workbooks. Learners, and not only teachers, need to refer to the study guides, section by section, as they use the workbooks. The workbooks contain hundreds of exercises that are done either in the book itself, in an exercise book, or as a topic of discussion. We'll give you some examples later. Exercises are all clearly marked using symbols explained at the front of the book. The core work, the main part of each chapter, includes short questions and word problems of varying difficulty. Most chapters have a mixed bag at the end, which have some revision questions, problem solving, and higher order challenges.
Right. Please take time, if you have the books, to read our comments at the beginning and also before the last chapter, which highlight the following: a selection of questions. No teacher or parent, let me say, should expect a child to complete the entire workbook within a year. It's impossible. It's far too much. I had some parents who said, I've bought this book, now my child will sit down in the Christmas holidays before the year starts and work through everything. Goodness me. Choose appropriate questions to fit the ability of the learner. Your fast able workers do not have to plod through every core exercise, and those who struggle should not get bogged down or discouraged by the challenging questions. Our thinking behind the problem solving and habits of mind is in the beginning of the last chapter of the study guide, where we explain the rationale behind all of this. And please, as parents and teachers, read those pages. However, don't underestimate your weaker child's ability to think laterally and solve problems. There are plenty of easy out-of-the-box exercises in this last problem-solving chapter in the workbooks, which give examples of each type of heuristic outlined in the corresponding study guide.
This key is at the front of the workbook. The following slides will explain the use of these different symbols. The little pen in the top right-hand corner is where space is given for children to write the answers in the book itself. This saves tons of time in the classroom, as learners don't need to redo numbering tables, column headings, etc. Teachers, how frustrating when we are waiting to get on with a lesson and there's 2 or 3 little ones who just haven't even written the date yet, let alone the numbering. These are examples where answers should be written in an exercise book. And this is not only to save pages in the book, it's because we don't want to limit the way in which a learner is processing and setting out their reasoning, which may also involve diagrams. These are examples of discussion topics, activities, and investigations, which the teacher can decide to do as a whole group or in groups. This all adds value and promotes understanding. And here we have some examples of higher order or challenge questions, which are all marked by the little asterisks next to the question number. Some of these need content knowledge, while others do not. This second question, the table, is so commonly seen in maths Olympiads. And once they've done 2 or 3 of these, understanding the principle of multiples, it becomes exciting, and even the weaker children can do this. And sometimes they don't need any content knowledge. Consider the first question on this page, the clock face. Sally.
Right. The answers, which are provided at the back of the study guide, are detailed. This saves a huge amount of time for teachers and allows the learners to self-mark where appropriate. Here's an example where it's just the answer given without there having to be any working. This is for those exercises where they would just write it in the space provided. The next slide will show more detailed answers where we show the working, not just the answer, or we show the diagram of what it should look like. The next slide will show where there is more than one method. So you can see in each of those, there's a method 1, a method 2, and we show different ways. And it was quite interesting when Penny and I were working on this, how our brains work very differently. We would often come up with totally different ways of solving a problem. And of course, there may be way more than just 2 methods. There may be 3, 4, 5 methods. And we really want to encourage learners to explore the different ways of solving something. Of course, they must be able to explain it logically and mathematically correctly. But again, it's that articulation of having to describe the way that they are solving that is so valuable in their understanding of maths. So we give a lot of this sort of alternative methods in our answer books at the back of the study guides. Right, some practical tips and ideas. I'll go through these quickly. The study guide. Oh my goodness, please actively encourage the use of these. Every learner should have his or her own study guide where they can write in it, annotate it, highlight it. We've got one school where the teacher used to set open book comprehension tests every week, where she would say to her class, okay, now take out your study guides and look up the answers. And she said that made such a difference in them understanding a section. It empowers the learner when they say, how do I do this? To say, well, before I answer, you go and look, can you find the answer yourself in your study guide? And this results in active engagement, long-term retention, a much deeper understanding, and less anxiety as they realize that they actually can work out the answers to themselves with the help of the resources at hand. Then the Swiss cheese method. I use this a lot, particularly with top classes, where we would introduce a new section. And as you're probably all aware, the math syllabus is far too big for the time allocated to it in a year. And I would say, right, go home, take out your study guide that you've still got from last year, revise for homework what you did last year so that that's fresh in your mind. Then I would say, take your study guide from this year, read over the new section. You won't understand all of it, but you will understand a lot, and I will fill in the gaps, the holes in the Swiss cheese the next day. And honestly, I think of a section like integers in grade 7. I used to be able to teach integers in 2 or 3 lessons because they had done this background Swiss cheese method themselves. Then the use of calculators. We are not in favor of calculators where there needs to be mental agility. It frustrates me no end when somebody in a shop will pull out a calculator to work out 10 Rand minus 6 Rand 50. But we do encourage them where the focus is not on the mechanical skills, but on exploring patterns and relationships between numbers or when working with very large numbers. I know some schools want to ban them completely. We feel that, there's a place for a calculator. Then obviously, as we've mentioned before, use concrete apparatus as much as possible. And a lot of these can be made cheaply from everyday products. One doesn't need to spend a fortune on equipment. Visual aids such as the 100 grid, multiplication grids can be helpful, especially for those with learning challenges. And Penny will talk about the tables and bonds.
Particularly about tables. These are examples of arrays, which are in the study guides, which are a vital and very underused tool for understanding tables. The teaching, learning, and understanding of tables is a huge area for research topics. In my own research, I connected with a UK professor who introduced me to the term automaticity. Rote memorization does not require understanding or thinking. So pushing children to learn and chant tables has its limit. Automaticity, on the other hand, relies on thinking. Answers are automatic, but focusing on the relationships between numbers is a vital part of this learning process. And this empowers children to apply the knowledge. So remember the terms rote or memorization compared to automaticity. So remember that these 3 grades of Workbooks have been tried and tested as Mathsfundi. So these reviews are from the Mathsfundi days. This first slide gives a few comments from teachers. And I'd like to focus particularly on the review at the bottom with a comment. If concepts are taught correctly in primary school, it saves us needing to undo poor understanding and reteaching. Neuroscience tells us, and our own practical experience backs up the fact that information learnt incorrectly is very difficult to undo. And it's especially challenging to undo neural pathways which have been firmly developed in the early years. Here we have a few reviews from parents. And then a few from the learners themselves. And that's us. Thank you. Over to you, Ina.
Oh, thanks so good. Thanks so much, guys. I think Penny, a lot of parents might cancel their KFC tonight to get these books. So yeah, but I think what's been clear throughout today's session is that you guys don't just know maths. You really understand how children think and how they learn, and I think that's such an important part of this book. So I would like to ask you, I think just one question that has been asked throughout the session was from Kelly, and she asked, what are the requirements for setting SAMF papers? So Sally, I don't know if you can perhaps answer that question. Otherwise, we can do some a bit more digging to answer it correctly.
Look, the SAMF, South African Maths Foundation, has got a committee that sets the high school papers. In fact, there are Olympiads for high school and tertiary, and then they go overseas and they participate in international competitions. And so Penny and I were appointed by the chairperson of that high school committee to work on the primary school committee, which is it's called the South African Maths Challenge, but it's essentially the junior section of that. And so we do have people who work on the committee at the moment. It's a set group, and we're all volunteers. But they're always looking for experienced teachers. So if you're very keen to get involved, we can always send your CV through. We can always forward it to the people who make the decisions as to who's going to be on that committee. There is a fair turnover over the years. There are about 4 or 5 of us for each grade. So we're looking at we've got about 25 people on the primary school committee. And it's fun. It's hard work, and we all volunteer.
It's a commitment. It's a commitment on and off throughout the year. And you need the ability to really analyze questions. We debate wording over and over. We debate the levels. We debate the types of questions, make sure that each paper has a range of questions. So it really does need a lot of commitment. And we need more people like Sally, who is fantastic at creating. She comes up with the most amazing brand new ideas. So that's where I take my hat off to her. But we need young blood.
Yeah.
So, Sally, I think people can find a way of connecting with us through Ina.
Yes.
Yeah. Okay.
So then we have another question by Joanne, and she's asking, what advice would you give student teachers who sometimes feel uncertain about whether learners truly understand mathematics being taught? So do you perhaps, are you able to provide some insight on that?
Apart from the obvious things like giving them an assessment to see, and we always gave baselines before we started teaching a topic so that we could see what they did understand or didn't understand before we even started. But I think getting learners in class to articulate in front of the class, in front of the teacher, often you'll pick up very quickly if there are misconceptions there. Bring them up. I remember going to a very
It looks like Sally's internet.
We've got Sally back. Okay. Let's wait for Sally to come back. In the meantime, I can also add there, the question of knowing whether children do understand or not. I think so often the teacher, you need to read those faces. Are the lights coming on or are they confused? Sally, you froze there for a few moments. And some little bodies are too nervous
Sorry, my
and anxious
internet
to
is
question.
unstable.
Yes, are too nervous and shy to ask questions in the class. And one of the big things, whenever a child does ask a question, is compliment them on coming up and asking the question and pointing out that probably they're not the only one who's unsure. So it helps you as a teacher to find out when they do not understand, when they need more help. Okay.
All right. And then let's see. Isabel is asking, this weekend we attended a launch of study lessons for math, and they mentioned that problem solving and solving problems are not the same. Do the books interpret these terms differently?
I'm not sure they're problem
What then?
solving and solving a problem. I think we would need some more context on that, some more information. If that this is it Isabel? Maybe you could send on the send us some more information and we can check all that and answer you more completely. Sally?
Yes, I haven't heard that those
Yeah.
are different.
Yeah. There's a difference between routine problem solving and non-routine problem solving. Not sure if they're referring to that. Okay.
Cool. So then Paul is asking, let me quickly see. Do you have an ebook version of the study guide? So we don't. I am sure, yeah. So the whole idea is to get students to write their answers and to really use pen and paper. I don't know, Penny and Sally, if you want to comment on that.
Yes, my understanding in dealing with our publisher is that Optimi and Snaplify are the two platforms where study guides, where the e-versions will become available. With our Maths Fundi books, we started off only having the study guides as ebooks, but all the effort in getting them ready and converting and doing the whole thing of getting them onto the platform never paid us back financially because so few people actually bought the ebooks. And the teachers would contact us and say, but they do need them. And they would we eventually made workbooks available as ebooks, but only for teachers to use for projecting in the classroom. The workbooks most definitely cannot be used by children. The ebook workbooks.
Yeah, we want them to have physical manipulation, to draw diagrams, to measure things with a ruler, to be able to write answers.
Okay.
Right. Penny, do you want to?
Yes, no, that's fine. I've spotted a question here, Ina. Will these maths workbooks replace the Maths Fundi books? If this is the case, would the old study guide still correlate? Yes, absolutely. As we've said, section by section, page number for page number, 100% correlation. The only difference is that the second workbook, the original Maths Fundi Part 2, those page numbers are obviously now added onto Part 1 for the Berlut workbook. I hope that makes sense. But if this lady, Kerry Lee, if you are interested, if you've got the Maths Fundi books, you've probably got our contact details, and you're welcome to connect directly with us about that.
And then we have another question. Do you provide term assessments per grade or not?
Sally,
no.
maybe we can talk about the worksheets. Did you hear that?
Yes, yes. My internet is unstable again, Penny. You talk about
Okay.
that.
All right. So, over the past few years, we have created many, many hundreds of extra worksheets, which our Maths Fundi schools all received as an add-on freebie. And we are busy working with Penguin on how to make this available to schools. So, that it will have that will come. As far as term assessments are concerned, we can't do an actual term assessment because not all schools are covering the same content in every term. And we have 4-term schools and 3-term schools. But there are tons of extra worksheets which could be used. Parts of the different sections could be used to create your term assessments if you wanted to do that. And those worksheets correlate section number by section number.
And the new
Okay.
workbooks also have quizzes at some of them have mental maths tests or quizzes at the back,
At
which
the,
is
at the back.
yeah.
Yeah.
All right. And then are there high school math books only for high school pure maths, or are there ones for high school maths literacy as well? So, Cherie, those are the Beloit books that you're referring to. So it's only pure maths that we provide at this stage. And
I
then
can. So, in discussions with our publisher, the literacy books hopefully will be in the pipeline in a few years' time. So, not yet.
fabulous. Well, that's great news. And yeah, so if today's session convinced you that these books deserve a spot on your bookshelf or perhaps at your kitchen table, you
Or
can
at your
find them,
school,
or at your
as a
school.
resource for the whole class, for all your children.
Yeah, you can find the books at leading bookstores or on our website. We'll also send you a order form after this webinar with the recording as mentioned and a free sample pack as well. And then, yes, I think that's it from our side. I hope you guys have a wonderful afternoon, and thank you so much for Penny and Sally for sharing your expertise with us. And we look forward to gaining a better understanding of maths because I think it's high time. Thanks so much, guys, and
Thank
Thank
you.
you all. Thank
we'll
you
talk
And
for
soon.
thank you all for joining us.
yes,
Thank you.
indeed.
Thanks so much, everyone.
Okay.
Goodbye.
Bye.
Bye.